So 11.2 worksheet. Um, we are going to be looking at a whole bunch of data sets, and I'm interrupting again. I hate it when I do that. I interrupt these guys so much. Oh, we're we're excited today. It's only Wednesday. Um, so we have a whole bunch of data sets that are programmed into the Rossmann one chance. Some of them I honestly have no idea what they mean, but we're just going to run with it. When you do paired data, where you ask everybody two questions, two numerical questions, and you plot their responses as a point on an XY axis. We put the explanatory variable on the x-axis and the response variable on the y-axis. And so let's go to one that I actually know. Okay, this one. Clear. So you hold on. All right, so we're doing least squares regression, which is up here on the left. So click least squares regression, and then you don't need to choose this. I'm going to choose the foot height. No. Okay, so here, 20 people were asked, how long is your foot and how tall are you? And then we plot all 20 points on this graph. Okay, and we draw our football around it. What would you guess is the correlation coefficient, the R value? Somewhere in the 0.5, 0.6 range. Is it going to be positive or negative? Positive because it's going up. Okay. So, does foot length cause people to get taller? Does getting taller cause people to have longer foot lengths? Yeah, and it's not so much that one causes the other. What is the confounding factor here, confounding variable? As you grow, you get taller and your feet get bigger. It's not like your feet all of a sudden enlarge and then that makes you grow taller, right? So in this case, does A cause B? Not really. Does B cause A? Not really. But we say that there is a correlation. The length of a foot is correlated with the height of the person. It doesn't necessarily mean that the foot length caused them to get taller. And in this case, it's probably C causes A and B. As you grow, both your feet and your height increase. Okay? So sometimes we can switch the X and the Y and still make sense of it. You can do that by pushing this explanatory response, and it just flips the X's and the Y's. Okay? So make sure on this worksheet that you're using explanatory comma response, except there are some questions which ask you to flip it. Okay? So what do we do with this football? Well, if we were to look at the seam of the football, you might think that that line is a pretty good prediction for how tall somebody is based off of how long their foot is. And it turns out it doesn't really work very well. So, look at these people. Does that blue line represent the 23 person very well? No. Does that line represent the 24 person very well? No. So if I were to keep looking at these people, that line does a pretty poor job of predicting people in each of those foot lengths. Okay? So there is something called the least squares regression line, and we're just going to call it the regression line because it's the one that everybody uses. And the least squared regression line is calculated by figuring out how far is a person from the line. Oh, let's use a different color. So this person is that far. Oh, sorry, I didn't draw the line. So the least squared regression line is going to go through the center of every column. So I look at all the columns and I put a center in there. And then I sort of draw the line that goes closest to the center of all those columns. Okay? And that's the line we use to make predictions. So if you came in and said that your foot length is 33, how tall would I predict that you are? So I would go over here to 33, and I would go up to the regression line, and then over, and it looks like, that's not very straight, is it? It looks like about 71. Okay? And there is a way to calculate the least squares regression line, and it's a huge nightmare, but I'll show you what they do. So what they do is they draw a line essentially, and then they calculate how far is each person from the line. Okay? And some of the people have a positive distance and some are above, and some have a negative distance because they're below. So how do we get rid of the negatives? Square them. So what that does is it essentially builds a square on every one of these. And then you add up all the squares, and you take the ends of that line and you kind of wiggle it around until those squares are as small as possible. Does that make sense? So let me show you what that looks like. Maybe. Oh, maybe I don't have it. Oh, well, I can't show it to you because the program has been removed from the system. So if you look at a whole bunch of different lines, you pick the one where the sum of all the squares is the smallest. And there's a big, fat, nasty, horrible equation where you can actually calculate it by hand. And it's awful, so I'm not going to do it. We're just going to ask the computer to do it. Okay? And that regression line is going to be the best possible prediction when you are given an x and you want to guess what the y is going to be. Okay? So, do I want to go over anything else before we do the first one? Correlation coefficient. No, I think we're good. Okay, so let's do the first one together. So, everybody choose Facebook. And make sure it says explanatory, comma, response. So if you click the green button, use data, it will pop it up. All right? Did you break it, Blake? I didn't break it. All right, so estimate the average and standard deviation for both the x and the y values. Now this is going to be a little bit hard because you can't draw on your screen. I don't know, maybe you can. So I'm going to draw my football. Okay. So it looks like this is the center of the y's and this is the center of the x's. So my x average looks to be about, I covered right over it, 4. And my y average looks to be about 0. Okay? And my sample standard deviation for x is going to be a little bit hard. How do we figure out the standard deviation? Well, what percentage of people are between 2 SDs and negative 2 SDs? 95%. So 1 SD plus or minus is 68. 2 SDs is about 95. So what we do is we cut off about 5%. So this is about 2.5% of the population, and this is about 2.5% of the population. So the distance from here to here is 2 SDs, and this is just an estimation. Okay? So how far is that? Well, that's the distance from 4 to 0, so that is a distance of 4. So what would my standard deviation be? 2. It'd be half of that, right? So my SDX is about 2. Then I do the same thing for the Y values. I cut the tips off, okay? And then I measure the distance from here to here, and it looks like it's about 2.2. From 0 to 2.2, so 1 SD is going to be about 1.1. And standard deviations are always positive. They can't be negative. Okay. So, if you, and it's really valuable for you to be able to do this, and you're going to check your own answer by clicking this button. I was pretty close. Right? Okay. Now the next question. So estimate the equation of the regression line. So remember, the regression line does not go through the seam of the football. Whether you're going up or down, the seam of the football is always steeper than the regression line. Okay? And the seam of the football is not a good predictor, especially when you're far from the average. If you're near the average, it will be, but if you're far from the average, it won't be. The regression line is going to go through the center of every column, and it will be less steep than the seam. All right? So I have a y-intercept of about negative 1.3. So y equals something minus 1.3. And then the slope's going to be kind of hard. So you're going to pick from 2 to 4. We went from about negative 0.5 to about negative 0.2. So my rise was 0.2 and my run was 2. So it's about 0.1. And we're going up, so it's positive. So 0.1x minus 1.3. Okay? Now hopefully by the end of this worksheet you are good at doing this. And you're going to check by going down here and show regression line. Well, I wasn't too far off. And notice they flipped those. So you guys are used to y equals mx plus b. But sometimes statisticians are snobs. And they do b plus mx. They actually say a plus bx. Yeah. It's the same equation. They've just moved the values around. Okay. So I was kind of close. All right. Now that we have the regression line drawn, the next question says, if someone had 2 friends, what is their predicted density? I don't even know what the density is. Oh, did I skip one? Oh, okay, sorry. R value. What does the R value look like? .5, 0.6. It's a pretty good football shape. So we click correlation coefficient. Oh, 0.366. Now, the reason that's the case, so normally when you have a football, you have a lot in the middle and then a few on the edges. Because this one does not have a concentration on the inside, That's why the correlation coefficient is so high, or so low. So normally when you have a football, you have kind of a denser section in the middle, and those all look pretty evenly spaced out. So guessing the R value can actually be quite difficult. Okay. Now, go back here. If someone had 2 friends, what is their predicted density? So we're going to use the regression equation. And we go 2 up to there, and that's going to be about -0.6. How do we check the answer? So we're making a prediction. So somebody walks in the room and they say, I have 2 friends. And so I want to predict, using the classroom data that already exists, I want to predict what their density is going to be before they tell it to me. So I look here, 2 gives me -0.6. How do I test this? I just plug it into the equation. So I put -0.6 in there. Oh, you're right, sorry. How about we put 2 in there? So -0.7 plus 0.2 times 2, and it's -0.3. Yeah. Yeah. Well, no. That's the prediction. My guess of the prediction was -0.6. The actual prediction is -0.3. And then that person's value could be anything. I don't know what the density means. I think it has something to do with, so we're looking at Facebook friends. I think it has something to do with the number of people in the area that you're dealing with. But I don't know. Not sure. Yes. Yeah, guess. So write down a number and then plug it in and show your work. Yeah. Okay. So next one. If somebody had 6 friends, what is their predicted density? So a new kid walks in and I said, hey, how many Facebook friends do you have? And they say 6. And I'll say, okay, so 6 hits the line there. And that's like 0.2. Okay. Now we take 6 and plug it into this equation. And it's 0.5. Okay. So if a person walks in and they have 6 friends, is that a guarantee that their density is going to be 0.5? No, but that's the best possible guess. So we use these regression lines to make predictions. How accurate are the predictions going to be? What determines the accuracy of the prediction? Having enough people. You do have to have enough people. It will be the R value, right? The farther the R value is from 0, so in this case, the larger the R value, the thinner the football, and the more accurate the predictions are going to be, right? So if we had this, how accurate are our predictions going to be? The line is essentially flat, and it's like a guess. We have no idea. But if I had these footballs, these predictions are going to be less accurate than those predictions because there's more variability about the line. That make sense? So you're going to guess the prediction just using looking at the table or looking at the scatter plot. And then you're going to plug it in to see what the actual prediction is. But the prediction is not going to be perfectly accurate. The accuracy is going to be based off of the shape of the football. All right. Okay. Number 6. If someone's density was 0.5, what is their predicted number of friends? Can I use this regression line to do that prediction? here's an admission. I took this class 5 times, right, over my statistical career. The first 4 times, nobody ever asked me this question, or if they did, I just assumed that the regression equation worked in both directions. But what was the value, by the way? What am I looking up? 0.5. Okay, let's look here. If I were to look at all of the 1.5 people, oh, that's not a very good job. Does that line do a good job predicting that? Oh, 1.5, sorry. 0.5. Does that line do a good job predicting those people? No, it doesn't even hit them. And if I did these people, and these people, and these people, and that, oh, these people, you can see that we need a new line. So the line that uses x's to predict y's is different from the line that is used to predict x's using y's. Did I say that backwards? I don't know. So one of them is called the x on y, and one of them is called the y on x, and I don't think this book cares. But you can't predict x's using y's with the regular regression equation. It's not going to work. So if I were to go to 0.5, and I look here, the middle of that row is about 3. And we can figure out what that is by just switching the explanatory and the response. So over here on the left, if you click this button, it'll flip. And then it will give you a new equation. And we can plug 0.5 into this equation. So 3.68 times 0.665 times 0.5, and I get 0. Oh, wait, nope. I did theta, not 0. How about 2.226? Somehow I put theta in my calculator. I don't know how I did that. Okay. Do all those questions make sense? Sure. I will guide you through the next one. All right, fatty acids. So we choose fatty acids. I have no idea what these mean. So on the x-axis we have copies. On the y-axis we have fatty acid ratio. Yes. Oh, thank you. So I need to go back to, no. It's not letting me switch it. Oh, okay. Thank you. Ah, okay. All right. So it needs to be explanatory response. Then we use data. So looking at that, estimate what you think the average x and average y are and what the standard deviations are. So I'm going to draw my football. So you're going to come up with your x average and your y average. And then you're going to cut the tips off of that, measure this distance, and then divide it by 2. And that is your standard deviation. Okay? I don't know. You do it. This one's kind of hard because there are only 3 answers on the x-axis, but that happens sometimes. Okay, and when you're done with that, you click descriptive statistics. Okay, and then the next one So estimate the equation of the regression line. So remember, the regression line is going to go through the center of each column. So the middle of that column, the middle of that column, and the middle of that column. So that is my regression line. Yep. So you're going to do y-intercept is about, oh, what would that be? Is about 17. And the slope is going to be about, so -3/1. Something like that. Where are you stuck, Taylin? Oh. Well, it's okay. I don't know how far off I'm at. Oh. So. Oh, I see what you're saying. Ah, good job. So, this is the y-axis. You're right, David. So, in that case, the y-axis is not the actual y-axis. Good job, David. That's the last time you get the answer right. Okay, and then you'll predict the R value, and then you'll use that regression line to predict the answers for each of those. Correlation coefficient. So this is the correlation coefficient. Okay, at the end, there is one question that says, okay, listen up. At the end, there is a question that says, what happens to the R value when you switch the X and the Y axes? So if we switch the explanatory and the response variables, what effect is that going to have on the R value? So I want you to make a guess, and then at some point during the worksheet, I want you to check it and see what happens. Okay? All right. Get to work.